Okay, perpendicular bisectors and angle bisectors. Even left a little bit of, so you guys can color these letters in if you want. Perpendicular bisector of a triangle is a line, ray, or segment that is perpendicular. Remember that that is the perpendicular symbol to a side of a triangle at the midpoint of the side. So here's your midpoint. And so this right here, this is your midpoint, these two. I'm going to call this M, then AB. M is perpendicular to segment AB, and line M bisects segment AB. So it tells you two things. It makes a 90-degree angle with the other side, and it cuts it into two congruent parts. All right. Next thing is perpendicular bisector theorem, and of course your converse. So here's the theorem right here. If the point lies in a perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. You guys kind of know this. So here we have our perpendicular bisector. I know that this triangle, ADC, is congruent to triangle BDC by side angle side. And if that's true, so if AD is congruent to BD, and CD is perpendicular to AB, then since this point is on the perpendicular bisector, AC must be congruent to BC by actually CPCTC. So it just basically says that if a point is on the perpendicular bisector, then it's equidistant from the endpoint. So this distance has to be the same as that distance. Okay? Converse is going to be the reverse. So basically, if a point is equidistant from the endpoints of a segment, like this guy is right here, so no, this distance is the same as this distance, then it is on the perpendicular bisector of a segment. So if this distance is the same as this distance, it basically says that this has to be a perpendicular bisector. We know that if these two sides are congruent, I know this angle has to be congruent to this angle, base angles theorem. I know CD is congruent to CD, reflexive property. So if AC is congruent to BC, then a line exists through C such that AD is congruent to BD, and CD is perpendicular to AB. Okay, so it just says if these, so if it says that if these distances are the same from each endpoint, then this, if I draw a line through its perpendicular, then it has to be also the bisector. So that's that. If BD is the perpendicular bisector of AC, or if BD is the perpendicular bisector, then I know this 5x minus 6 must be equal to 3x plus 8. So x must be equal to 7. for the next example, if I know that this is the perpendicular, if this is perpendicular and bisect, I know this distance has to be the same as this distance, because if it's perpendicular and bisects, it has to be equidistant from the endpoints. So I know 7x minus 22 must be equal to 4x plus 5. 3x minus 22 is equal to is equal to 5 plus 22 plus 22. Sorry guys, interrupted. 27 divided by 3 divided by 3. X is equal to 9, but we need to substitute, so let's find RS. RS is going to be equal to 4 times 9 plus 5, which is 36 plus 5, so RS is equal to 41. So segment JK is formed by J and K. So J is -7, -8, and K is 1, 4. Is L on the perpendicular bisector? So we have -9, 2. Is L on the perpendicular bisector? Well, if it is on the perpendicular bisector, then this distance is going to be the same as this distance. Okay, that's how we guarantee it. If those distances are the same, basically if it makes an isosceles triangle, then I know that it has to be on the perpendicular bisector. And I mean, there are other ways that we could do this. We could find the midpoint and see if this is perpendicular and find this distance and this distance. But the easiest way is to find these sides. So we have JL is equal to -7 minus -9 squared plus -8 minus 2 squared. So JL is equal to 2 squared plus -10 squared. JL is equal to 4 plus 100. Distance from J to L is equal to 104. Okay, then I go from L to K. So from L to K, -9 minus 1 squared plus 2 minus 4 squared. LK is equal to -10 squared plus -2 squared. LK is equal to 100 plus 4. Distance from L to K is also 104. So since this distance is the same as this distance, since it's equidistant from the endpoints of the segment, so this is an end and this is an end, then the answer must be yes. Okay, it has to be on the perpendicular bisector. Concurrent lines are 3 or more lines that intersect at the same point. Point of concurrency is the point of intersection of concurrent lines. So concurrent lines would be here, here, and here. Okay, they'd all have to intersect at one spot like that. Okay, so you have points of concurrency. So we did this in class where we found all of the perpendicular bisectors. So here we have a perpendicular bisector here for this side. We have a perpendicular bisector here for this side. and we have a perpendicular, oops, sorry about that, and we have a perpendicular bisector for this side, and so we have point P there that's kind of in the middle. So in this case, the point of the perpendicular bisectors of a triangle always meet in the same spot, so it's called the circumcenter. Okay, the reason why it's called a circumcenter is because when you construct all the perpendicular bisectors, it makes, so if you put your compass on this point here and then your pencil here, it actually, you can draw a perfect circle that goes all the way around the figure, okay? And it hits each vertex, your circle does. So a circumcenter is the point of concurrency of the perpendicular bisectors, okay? Sorry, perpendicular bisectors. Right, so this is a little extra though. Alrighty. The perpendicular bisectors intersect at a point that is equidistant. So we're going to talk about point P again from the, well, this distance, and this distance are the same. They are all radii. Cannot spell radii. Radii of the circle. These are all radius. So it's actually, they're equidistant from the vertices. So PA, PB, and PC are all going to be the same. Things that we explored in class: the circumcenter of an acute triangle is inside. The circumcenter of an obtuse triangle is always outside the triangle. And the circumcenter of a right triangle is on the triangle. In particular, it is on the hypotenuse. So, first example, we only have one example of that. It's circumcenter, so that's going to be your perpendicular bisectors. Okay. So I look at this and I know that these are all perpendicular bisectors. So I know this one right here, I know this is congruent to this, and it is perpendicular. I know that this is perpendicular, and this side is congruent to this side. And I know this is perpendicular, that guy right there, and I know this side is congruent to this side. And the last little piece of information that we need to use is I also know that it is, these distances are all the same, because I could draw a circle that would go around perfectly all around this, but you guys are just going to have to believe me, because that's not going to happen on Microsoft Word. So knowing that, I use that information. So I know if this is 34, then this has to be, I know this has to be 17 and 17. I know if this is 19, this one over here is 19. Okay, so that helps me out, because I know that, so do I know TU yet? TU is going to be 38. VY is 17. UZ, well, if this is 21, this one's 21, and this one's 21. So UZ is 21. WV. So WV is going to be a bit more challenging, because we have this little right triangle, okay? This triangle right here. And I know that 15 squared plus WV squared plus WV squared is equal to 21 squared. So 225 plus WV squared is equal to 441. WV squared is equal to 216. WV is equal to the square root of 216. Now we can simplify our 216. You can either find the largest perfect square or you can divide by 2. 216 divided by 2 is 108. 108 divided by 2 is 54. 54 divided by 2 is 27. 27 can't be divided by 2, can be divided by 3 9 times. 3 and 3, 3 and 1. So I know 216, so WV is equal to, well, the square root of 4 is 2, so I know that comes out. The square root of 9 is 3. And then we have a 2 and a 3 on the inside, so it's going to be 6 radical 6. Okay. And last but not least is TV. Now TV is going to be 2 times 6 radical 6 because it is 2 times WV. So that's going to give me 12 radical 6. Okay. Always only outside, outside, inside, inside. So there we go. All right, next thing, angle bisector theorem. If a point is on a bisector of an angle, then the point is equidistant. We like that word with this unit. From the sides of that angle. So if this angle is congruent to this angle, this distance is going to be the same as this distance. And distance always has to be perpendicular. You're not going to count the distance from here to this side like this, okay? Because that is not how, that's not the shortest to get from here to, or to get from this line to this line. The shortest distance is actually going to be right across. Okay, it's going to be that perpendicular distance. So if angle AD, or if AD bisects angle BAC, and AB is perpendicular BD and CD, so that's what it's talking about here and here, then segment BD, the distance from the distance from that point to one side is equal to the distance from that point to the other side. So BD is congruent to DC. Next one, if a point is on the vertex of an angle, or wait, it's on the bisector should be if the point is equidistant from the sides of an angle. point is on the interior, that's the word I was looking for, or an angle, and equidistant from the sides, then the point is on the angle bisector. So that just basically means if it's on the inside of the angle, like point D is, and we know that these distances, it's equidistant from the sides, then this right here has to be the angle bisector. And if that's the angle bisector, then this angle must be congruent to this angle. So if I know that BD is equal to CD, angle BAC AB is perpendicular to BD and AC is perpendicular to CD, then you know AD bisects angle BAC. And the other thing you know is angle BAD must be congruent to angle CAD. There we go. All right, so these little indicators, that means that angle those two angles are congruent to each other. If these are perpendicular, then I know this distance has to be the same as this distance, so I know 13x minus 4 is equal to 8x plus 11. So basically just because it's equidistant, or because it's on the angle bisector and equidistant, and those distances are perpendicular, those distances have to be congruent to each other. So minus 8x, 7x minus 4 is equal to 11. Correct, 7x, that is not right. Is equal to 11 plus 4 plus 4. 5x is equal to 15. X is equal to 3. If I know x is equal to 3, it says find AD. So AD is equal to 13 times 3 minus 4 is equal to 39 minus 4. Distance from A to D is equal to 35. And then here, I know this distance, and I know its distance because it's perpendicular is congruent to this distance, which means this has to be an angle bisector. Knowing that, 8x minus 32 must be equal to 3x plus 3. 5x minus 32 is equal to 3. 5x is equal to 35. X is equal to 7. But it says find the measure of angle XWZ. That whole angle. Well, I know this is 3 times 3, or 3 times 7 plus 3, which is going to be 24. And this is 8 times 7 minus 32, which is 56 minus 32, which is also 24. Okay, so I know that then the measure of angle XWY must be equal to 24 plus 24, which is 48 degrees. Okay, last thing for today is the incenter. Incenter is point of concurrency of the angle bisectors of a triangle. Incenter is always inside the triangle. Angle bisectors of triangle intersect at a point that is, well, in this case, this is actually equidistant from the sides, which we know. So, which means that if you draw all the distances from your incenter to the sides, and we know it's distance because it's perpendicular, if I draw a circle where P right here, I put my point on P and put my pencil on where it intersects the side, it makes a perfect circle. This is actually called, this is inscribed. Okay, that circle is inscribed. I can go back up to this one. This circle is circumscribed. Scribed means to write, and circum means around. So this is written around, and then inscribed, of course, is going to be on the inside. Scribed is going to be written, so it's written on the inside. So angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So I know PD is the same as PE, which is the same distance as PF. So G is the in-center, or sorry. I did not give you the correct diagram. Okay, we're going to change the letters here. So this should be NP, NK, so this is going to be P, is in center of triangle JKL. This is NP, NK, PK, and LO. So if I know that this is the in-center, I know that angle is the same as that angle. I know this angle is the same as this angle. And I know this angle is the same as that angle. I also know if it's the in-center that this distance, and this distance are all the same. So if this is 8, this is going to be 8, and this is going to be 8. I know this is perpendicular. Okay, so let's go through. It says NP. Well, I know NP has to be 8 because it's equidistant from the sides, and one of the distances is 8. It says find NK. So NK, since these triangles are congruent, if this is 17, this one right here also has to be 17. So NK is 17. PK, which is this long guy right here, well, I can do Pythagorean theorem. I know that 8 squared plus 17 squared is equal to PK squared. Like squared plus like squared is equal to hypotenuse squared. So 8 squared is 64 plus 289 is equal to PK squared. That's going to be 353 equals PK squared. PK equals the square root of 353. And I can't think of anything that goes into 353 for right now, so I'm just going to leave it like that, unless I can think of maybe 17 or something. Okay, so PK is radical 353. Okay, and the last one is LO, which is, okay, so that's going to be 8 squared plus LO squared is equal to 13 squared. 64 plus 100 is equal to 169, or plus 100 plus LO. LO squared is equal to 105. LO is equal to the square root of 105. Okay, I know you can divide it by 3. That's 35. Divided by 5 is 7. 7 and 1, so that's all I can do with that one. So that one's going to be radical 105. So a little bit of Pythagorean theorem there. All right, next. If I know S is the incenter, I know it's equidistant from the sides, so if we had these distances, those would be the same, but unfortunately, or we don't have those, so we don't have to worry about it. So if I know it's the incenter, the other thing I know is that this angle is congruent to this angle. I know that this angle is congruent to this angle, and this angle is congruent to this angle. It says that PRQ, so this big pink angle, is, so this angle right here, the whole angle, is 8x minus 10. It says that RPQ, this whole angle right here, is 4x minus 14. And this angle right here is 7PQR, is 7x minus 5. And I know that these angles are 180, so I have 4x minus 14 plus 7x minus 5 plus x minus 10 is equal to 180. So it's 19x minus 29 is equal to 180. 19x is equal to 209. X is equal to 11. Okay, 7 times, so x is equal to 11, so I know that this is going to be 7 times 11 minus 5, which is 72 degrees, which means each one of these angles is going to be 36 degrees. I know this angle right here is 8 times 11 minus 10, which is 78 degrees, which is 39 degrees and 39 degrees. And this is 4 times 11 minus 14, which is 30 degrees. So that's going to be 15 degrees and 15 degrees. So PRQ, so angle PRQ was 78 degrees. And we know PRS is 39 degrees. I know that RPQ is 30 degrees. RPS is 15 degrees. PQR was 72 degrees. PQS was 36 degrees. And for this last one here, So PSR, this angle right here, that little orange angle, well, I know that's going to be 180 minus 15 minus 39. Okay, which is going to be 126 degrees. And there you go. That's all you need to know about these guys.